One of the first measurements we do is what we call the Strevel measurement. It's a combination of straightness and leveling. What we do is we position two pair of sensors in the machine, two laser sensors, one on the table and one in the spindle. In addition, we also place two leveling sensors. Each sensor has a two-axis leveling capability. So it's measuring two directions. And we place one level sensor which is used as a reference on the table. It's marked the R. And the other one, marked M, is placed on the spindle, which is also measuring the angular deviation in two directions. So for doing this measurement, we enter a program for Strevel. And in this particular machines, we do not have any bed slant. It's in 0 degrees, so we just confirm. And now we do the configuration of these measurements. We will measure the straightness in the set direction in 5 points. And the starting point is in this position, which is minus 180 in the set axis. We will go up to position 80, plus 80 for the 5th point. So I'm actually pointing at one, enter 80, and it divides that distance into equally distributed points. So we now have 5 points between those positions. We enter the tolerances for the straightness. In this case, it's 20 microns, confirming that. And we're also telling this tolerance for the angular deviation, which is 40 microns per meter. All these are referring to the standards from the machine supplier or from ISO standards. When we have done the configuration, we confirm that, and we go into the measurement screen. And here we can define the axis where we're measuring in. It's, in this case, it's the y-axis, which is in and out, and the x-axis side to side. So you can choose whatever axis you are measuring in, and you do the naming by entering the different coordinates in the coordinate directions in the machine. So in this case, we already have that. We start the measurement going into position number 1, is a point 1. To your left, you will see the values from the laser sensor. On the right, you will see the values from the level sensors. In this case, it shows in 2 directions, alpha and beta, from the M unit. You start the measurement by recording this first point, by pressing the record button, the blue one, and we take readings from all sensors in the system. We put these recorded values to 0, and you can also see that the position number 1 is now filled, and we are at position minus 180. We now go to the next point, number 2, and on the screen you see that the ring around number 2 is blinking, telling us that we have not measured, and above that it stands minus 115, which is the position we want to obtain. We start moving the machine by the CNC system to minus 115, and after waiting for about 15 seconds for the values to stabilize, we can record the values by pressing the blue icon again. The number 2 will be filled, and we can continue to number 3, which is in position minus 50, and we're moving the machine. And if you have prepared a program already in the CNC system, we can do this positioning very quickly. We record, take the readings, and we can continue to point number 4, which is in plus 15. And when we are in place, we start recording. And finally, we get to the last position, which is number 5, in position plus 80. We record. And now we have taken the readings in all 5 points. I will set number 5.0 as well. And then we go to the diagram and we will see the results. In this case, we see the straightness first, and we see it in 2 directions, in the Y direction, in and out in the machine, and side to side in the X direction. In the Y, we have obtained a maximum difference of 2 microns for this machine. And in the X direction, we see a maximum difference of 3 microns on this distance. So it's well within the tolerances. Simultaneously, we have measured the angular deviation of this axis of motion. We can see in the alpha direction that we have a difference of 4 microns per meter. For the beta direction, which is side to side, it's a maximum deviation of 5 microns per meter. This is very good in this case and well within the tolerance. The diagram that is shown here is from the M sensor. And we can also switch to the R sensor. And this result is telling me if we have any movement on the machine foundation, because we have placed the R sensor on the table, which is fixed during the entire measurement. And in that case, we can see if there is any movement due to the weight moving up and down in the machine. The other result we can obtain is actually the difference between the M readings and the R reading, which is actually telling me the twist of the Z-axis movement. So we save all these results and we call it Strevel set. And we confirm. And all of these results are now saved both graphically and numerically in the memory of the display box, which later on can be exported, or we can create an on-site measuring report in PDF format directly on site.